Hello everyone and welcome back. Today we are going to dive into a classic topic that still confuses many newcomers and even some experienced developers. What's the real difference between C and C++? And more importantly, why does it matter? Let's get started. When people talk about C and C++, it often comes with the question, aren't they basically the same? Or C++ is just C with classes, right? That's partially true, but also very incomplete. C and C++ share a lot of syntax, and yes, C++ was originally built as an extension of C. But the philosophical, structural, and practical differences between the two are huge. To understand this, let's start with the basics. C is a procedural programming language. That means it's all about functions, control structures, and linear sequences of instructions. Code is organized into functions and data structures, but there is no concept of classes or objects. C++, on the other hand, is a multi-paradigm language, but primarily object-oriented. It supports procedural programming like C, but it also adds classes, inheritance, polymorphism, and encapsulation, the pillars of object-oriented programming. So what does this actually mean? Well, here is a tiny example. In C, you might write this. In C++, you could encapsulate this into a class. Same functionality, but the C++ version combines data and behavior. That's encapsulation. In C, data and functions are separate. In C++, they live together, which is a huge deal for organizing large codebases. Another key difference is how the two languages approach abstraction. C gives you full control. You manage memory manually with malloc and free. You can do pointer arithmetic, and you can manipulate raw memory. This makes C very powerful but also very risky. There is no safety net. You can easily have buffer overflows, memory leaks, dangling pointers, and no compiler warning will save you. C++, in contrast, offers an abstraction mechanism that helps prevent these problems, if used correctly. You get constructors and destructors, smart pointers, RAII, and the standard template library. Instead of writing manual memory management code, in C++ you can often do something like this. There is no manual memory allocation, no manual cleanup. The stud vector handles everything internally. This improves code safety, readability, and reduces bugs, but it also comes at the cost of a slightly steeper learning curve and potential overhead if you don't understand what's going on under the hood. C is minimal. The standard library is small and the language has a limited number of features. This makes it lean and fast, especially in embedded systems, microcontrollers, or operating systems where every byte counts. C++ is a much larger language. It supports templates, exceptions, multiple inheritance, function overloading, operator overloading, and much more. This richness allows developers to write complex systems more quickly and with better structure, but it also means you can shoot yourself in the foot in a very complex way if you misuse these features, so there is a trade-off. Minimal and bare bones versus powerful and feature-rich. C uses macros to achieve generic behavior, but macros are dumb. They are handled by the preprocessor and don't respect scope, types, or errors. Here is an example. Looks simple, but this can cause bugs if A or B have side effects. C++, in contrast, uses templates, which are type-safe and part of the language itself. The compiler type checks this. It behaves like a real function. This allows for powerful generic programming, which is the basis of the STL. This one is massive. The C standard library gives you basic input-output, string manipulation, memory functions, and that's about it. In C++ you get the STL, a whole bunch of data structures and algorithms. Need a hash map? Use std unordered map. Need a dynamic array? Use std vector, and they all come with iterators, algorithms, and memory management built in. This doesn't just save time, it standardizes code and improves reliability. C doesn't have built-in exception handling. You use return codes and manually check for errors. In C++ you can throw exceptions. then catch them. This leads to cleaner error handling and separation of concerns. But again, it adds complexity. Another important difference is how the languages handle compilation. In C, the compilation model is simpler. Every C file is compiled into an object file, and then they are linked together. The function definitions must exist at link time, or you get errors. C++ adds templates, inline functions, function overloading, and those complicate the compilation process. Templates, for example, are instantiated at compile time. This can lead to longer build times and larger binaries, especially if used heavily. So if you're building large systems, managing compilation in C++ can become a serious task, especially without tools like CMake or build systems like Bazel. So where is each language used? C is still dominant in low-level systems, operating systems, embedded firmware, device drivers, and kernels. Why? Because of its low overhead, speed, and fine-grained control. C++ on the other hand is used in applications where performance and structure are needed. Game development, financial systems, simulation games, browsers like Chrome, these are often built in C++. In fact, most AAA games are written in C++ for a reason. You get the power of C with higher level abstractions, which are crucial for managing large code bases. Now here is a tricky question. Can C and C++ work together? Yes, mostly. C++ is in a way a superset of C. Most C code can be compiled as C++ with minimal changes, but not all of it. There are subtle incompatibilities, for example, implicit void pointer conversions that work in C but not in C++. To call C code from C++, you typically wrap it like this. This tells the compiler not to mangle names so it can link properly with C code. But calling C++ from C, that's harder, because C doesn't understand classes, exceptions, or templates. So if you need two-way compatibility, you have to be careful. This is the most subtle, but perhaps the most important difference. C was designed by Dennis Ritchie to be close to the machine, simple and portable. It gives you just enough abstraction to be productive without getting in the way of performance. C++ was designed to scale, to manage complexity in large software systems. It's about abstraction, reuse, and flexibility. That's why C++ keeps adding features. Lambdas, const-expr, modules, concepts. It's evolving to support modern development needs. C, on the other hand, has remained more or less the same over the decades. So the question is, do you want full control or structured abstraction? That's what it boils down to. Alright, so why does any of this matter? It matters because when you choose a language for a project, you are not just choosing a syntax. You are choosing a philosophy, a toolchain, a runtime model, and a trade-off. If you are building firmware for a washing machine, use C. If you are writing a physics engine for a 3D game, use C++. If you want fine control over performance and memory, C might be better. If you want scalability, templates, and safety, C++ shines. And as a developer, even if you specialize in one, it's critical to understand both. Many real-world projects combine the two. To wrap it up, C is fast, reliable, and dangerous. C++ is powerful, flexible, but harder to master. Neither is better than the other. They serve different purposes, and the best programmers know when and how to use each one. So the next time someone says C++ is just C with classes, you will know how to answer. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe, and check out the playlist on the screen. See you in the next one.